students, it's Miss Culver. It is April 29th, it's a Thursday. I just got off Zooms with you and Lucas Schock, it was so good to see you. He said he needed help on the con topic, tangent identities, periodicity. And I also talked with Stella and she said she needed help on special trig values of special angles. Those happen to be on the unit circle. So what I've done is I've made a unit circle here. Just so you know, along with this video on tangent identities and along with another video I'm going to send on trig values in special triangles, I am going to send you a picture of the filled in unit circle. Next week, one of your jobs highlighted in yellow will be to watch my unit circle video where we fill this beautiful circle in, because all of these values really make sense. But for today, I'm just going to present them to you as they are. You did study them in Algebra 2. Okay, and we're going to take a look at that. So I quickly made this unit circle. Notice in red, what I have is the degree measure and its equivalent radian measure next to it. On the outside in blue, I have the cosine, sine, and tangent values, right? So if you notice, cosine will be the first value. In parentheses, sine will be the second value, tangent will be the third value on the outside. Notice that kind of goes in alphabetical order, right? I also included that when you rotate upward from 0 degrees or radians, that would be a positive angle. And if you rotate downward, that would be a negative angle. I also included on the unit circle, as if there was an XY axis that the circle was laying on top of, where X is positive and where Y is, and where X is negative and Y is negative. Okay, so talking about tangent periodicity, let's take a second though and see, let's see where Kidders is. I am shooting this video on my own, so it is going to be jiggling around a bit and moving in and out. There's Kidders, because Kitty doesn't have any opposing thumbs to shoot the video, but isn't she beautiful? Hi, sweetheart. Yeah, and my brother and Bill are not here to help me, so I'm hoping I do a good job for you. So, number one, what I want you to know is that cosine and sine values both repeat every 2 pi. That would be every 360 degrees on the unit circle. Well, when you take a look, of course that makes sense, right? If you are at an angle measure and you rotate 2 pi, which would be 360 degrees, that means you're going all the way around the unit circle once, and of course, you are landing in the same place you started. So of course the cosine and sine are going to be the same, and the tangent, okay? Now, what I want you to know though, is that on the unit circle, and you'll see this more when you watch my unit circle video, cosine is the X value for good reason on the unit circle. Sine is the Y value, okay? Tangent, for good reason, is actually Y over X, like an opposite side over an adjacent side. Right? And so what happens then with tangent, yes, it repeats every 2 pi because you've gone around the unit circle once, but it actually repeats more often. Take a look at number 2. Tangent values repeat every pi, every 180. So if you started an angle measure on the unit circle and you swing 180 degrees, a half circle from that angle measure you're at, you will see the same tangent value. So let's just see if that's true. Let's start at pi over 6. Notice the tangent is the square root of 3 over 3 there. Okay, I'm going to start at pi over 6. I'm going to go upward. I am rotating half a circle. I'm going 180 degrees or pi around the circle. Oh, look at there. I land at 7 pi over 6. Look there. The tangent is the same as where we started, the square root of 3 over 3. Okay? The reason why tangent repeats twice as often is it depends on Y and X, sine and cosine, so it changes twice as often. What I also want you to know is that in any right triangle with the same acute angle, So, I mean, let's say you have a right triangle with a 30-degree angle in it. You can place that triangle anywhere, and the cosine, sine, and tangent values are going to be the same. You could take a right triangle with a 45-degree angle. Doesn't matter where you place it, the cosine, sine, and tangent values are going to be the same. Okay? The only thing that will change is whether the values that are staying the same are positive and negative based on where that triangle is on the unit circle. Right? If you place that triangle where the x's are negative, your cosines are going to be negative. If you place that triangle where the y's are negative, your sines are going to be negative. Okay? Now, here is an example that they did on Khan Academy in the video, but I chose a different value. Okay? So, here's how Khan Academy said it in the Tangent Identities Periodicity video. One angle whose tangent is 1 is 0.785. That happens to be pi over 4. So Khan, they tend to use decimals, but on the unit circle, we don't really use decimals. We use the exact values with the pi's in them. Okay? What other angles have the same tangent? So let's first see if this is true. Let's go to pi over 4, this angle, and let's see if tangent actually is 1. So let's go over to the unit circle. Let's go to pi over 4. There it is. Yep, the tangent is 1. Okay, what does this mean? What other angles have the same tangent? This is what it means. We said that, first of all, we know that tangent of pi over 4 is equal to 1. And what we also know is that if I start at pi over 4 and rotate pi, that at that angle measure, tangent will be the same because tangent repeats every 180 degrees every pi. So what that means is if I take tangent of pi over 4 and I rotate, I add another pi to that angle, I should see there that tangent's also 1. Now I could add another pi. That means if I take tangent of pi over 4 and I rotate not just 1 pi but 2 pi's, that I should see that the value of tangent at that angle right here should also be 1. Let's go to our unit circle and see if it's true. We already checked that tangent of pi over 4 is 1. Let's go to pi over 4. Rotate pi and check the tangent. Let's do that. So at pi over 4, there we go. Let's add a pi. I'm going to add a half circle. Here I go. There I go. Oh, there I am at pi over 4. Yep, tangent is 1. Let's start back at pi over 4. And let's add 2 pi. Let's start at pi over 4. Let's add 2 pi. Well, wait a minute. That's a whole circle. Okay, I'll just start at pi over 4 and rotate all the way around once. Well, of course the tangent's going to be the same. I'm at the same place. There we go. And those are the answers in the circles that Khan Academy was looking for from you. I just want you to know that because when you rotate downward or counterclockwise, that's a negative direction. Isn't it true that if you have tangent of pi over 4, there you go, and you start at pi over 4 and you go downward minus pi, a half circle, of course you're going to end up at 1 also. So I just want you to know this would be an answer also. Let's take a look. Let's go to pi over 4 for tangent. There it is. I'm going to go downward a half circle. There we go. Oh, of course, tangent's 1. So I hope that this helps you with this section, and I hope it makes sense, and I hope you have a great day. Bye.